So, looking to understand better trigonometric functions, or at least have a better grasp of inverse trigonometric functions. Well, if that's the case, welcome to Math Tutorials 82, where we work together to master the skills that will set you up for success. So, before using any trigonometric functions, it is always best to know where they came from and test their validity. So in a previous video, I showed how we could obtain the three basic trigonometric functions which are sine, cosine, and tangent using a triangle or Pythagorean theorem, as well as from a circle using pi, which is 22/7, or approximately 3.14. So I will link the description to these videos at the end of this video. So, what are the inverse trigonometric functions? Well, those are the following. Cosecant, which is 1 over sine, secant, which is 1 over cosine, and cotangent, which is 1 over tangent, or cosine over sine. So, before we proceed, we will show or do a recap of sine, cosine, and tangent. So what does cosine and sine look like? They look as follows. So from 0 to 2 pi, this is what cosine and sine look like. So sine is the orange line, which starts at 0, and cosine is the blue line, which starts at 1. And so this is what they look from 0 to 2 pi. So this graph is in radians. For tangent, which is sine over cosine, this is a very rough sketch of what it looks like. And the reasoning is because, as we will show, when you compare them, sine and cosine, let's make this a little bit smaller. There's going to be parts where cosine is going to be 0. So at pi halves and at 3 pi halves, tangent is not going to be continuous. It's not going to be a continuous line because it will tend towards infinity or negative infinity in those two boundaries. So here, Excel shows them as a continuous line, but we're going to have limiting boundaries right there because cosine will tend to 0 right there, so that'll make tangent go to infinity or negative infinity. Meanwhile, sine will just make tangent go to 0 when it touches 0, which would be pi and 2 pi. So she's shown here. So what does cosecant, secant, and cotangent look like? Simple. I will provide a demonstration of how these functions work between 0 and 2 pi. Now let's go to the demonstration. So now we'll do the following demonstration. We have cosecant equals 1 over sine. And so here we have sine, which starts at 0 and becomes 0 at pi and also at 2 pi. So in that case, it's going to have a boundary at 2 pi, at pi, and at 0. So what does cosecant look like? So it goes from infinity down to 1 at pi halves, and then it goes back to infinity. From pi to 2 pi, it goes from negative infinity to minus 1, and then back to negative infinity. For cosine, since we have secant equals 1 over cosine, cosine is 0 at pi halves and 3 pi halves, so we're going to have those two boundaries. From 0 to pi halves, since it's still positive, it's going to go from 1 to infinity. Then from pi halves to 3 pi halves, it's negative, so it's going to go from negative infinity to minus 1, and then goes to negative infinity again. From 3 pi halves to 2 pi, it's positive, so it's going to go from infinity down to 1. For cotangent, it's going to be, there's going to be infinite when sine equals 0. So it's going to have the same boundaries as sine. So in 0, it's going to have a boundary. In pi as well. And in 2 pi. So what's it going to look like? Since from 0 to pi, sine is positive up to pi halves, and cosine is positive, it's going to go from negative infinity to 0. Because at pi halves, cosine is 0. So the two spots where it will be 0 will be at pi halves and 3 pi halves. Then from pi halves to 2 pi, cosine is negative, but sine is positive. So this is going to go negative infinity as such. From pi to 3 pi halves, both sine and cosine are negative, so it's going to be positive. So it's going to go from infinity down to 0, and then from 3 pi halves to 2 pi, cosine is positive, but sine is negative. So it's going to go down to negative infinity as such. So if you saw the demonstration, you get 1 gold star. Now we will look at 2 common trigonometric functions, or properties. These would be cosine of 2 times the angle is equal to cosine squared of the angle minus sine squared of the angle, or sine of 2 times the angle equals 2 times cosine of the angle, sine of the angle. So now we'll go to the demonstration and see how this all works. So we'll start with the following demonstration. So we have that cosine of 2 is equal to cosine squared of theta minus sine squared of theta. So we know that cosine of an angle, of two angles, equals to cosine of A cosine of B minus sine of A sine of B. And so, in this case, we have cosine of 2 theta plus 0 equals cosine of 2 theta cosine of 0 minus sine of 2 theta sine of 0. So this becomes 1, this becomes 0. That's equal to cosine of 2 theta. So that holds. So then we'll do the following. Cosine of theta plus theta equals cosine of theta minus sine of theta sine of theta. And that equals to cosine squared of theta minus sine squared of theta. So we'll also demonstrate that sine of 2 theta is equal to 2 sine of theta cosine of theta. So we have that sine of A plus B is equal to sine of A cosine of B plus cosine of A cosine, sine of B. And so if we have sine of 2 theta plus 0, that equals sine of 2 theta cosine of 0 plus cosine of 2 theta sine of 0. So we have this goes to 0, this becomes 1, so that's equal to sine of 2 theta. So this holds, so we can use it. So sine of theta plus theta equals sine of 2 theta, and that equals sine of theta cosine of theta plus cosine of theta sine of theta, and that equals to 2 sine of theta cosine of theta. So that finishes our demonstration. So if you saw that second demonstration, you get 2 gold stars. So now that we saw how these trigonometric functions look and demonstrated their validity, we will now use MATLAB to see how they look or how they can be obtained in real life. So everyone, welcome to MATLAB Simulink. So we're going to be testing out that that function for which we did the demonstration earlier. So this top portion, we're going to have a value that's going to go from, with a slope of 2, is going to be fed into a trigonometric function, and we're going to have the result. And if everything is adequate, that means that this sine, which is a cosine since it's pushed back half pi, and this sine, which is twice the amplitude, so it's 2 times sine of the angle, are multiplied together. These two functions should get the same value. So I'm setting the timer for just pi, 2 pi, and let's see what happens. So let's open one, and let's open. So here we have the first function. Now let's open up the second one. And it looks like both functions got the same value. So let me get this one. So the way we can tell is by looking at 1 here. They cross at the same side. So at 1, they cross at the same side. So yes, so this demonstrates that sine of 2 times the angle equals 2 times sine of the angle times cosine of the angle. So if you saw the MATLAB demonstration, you get 3 gold stars. And so this comes to show that it is essential to know, or at least have a good understanding of common trigonometric functions, since these will be used in real life. So if you've enjoyed the video, I guess I will see you in the next one.